This is part 1 of solving equations containing radical expressions. Remember, radical expressions might have some square roots or cube roots or fourth roots, etc. And in solving equations of this form, we're going to be using the power rule. So here's the power rule. If both sides of an equation are raised to the same power, all the solutions of the original equation are also amongst the solutions of the new equation. So what that means is, if we square both sides of an equation and we find the solutions there, then if there was a solution to the original, it'll still be there in the new equation. But the reverse is not true. So this is the basic warning. The warning is make sure you check your solutions in the original. Okay, because you might come up with something that is a solution to our new equation that wasn't really a solution to the original. So let me show you an example. Let's say we've got x equals 3. Okay? Now, let's take and square both sides. So you can see me doing this. Let's square both sides. So now I've got x squared equals 9, for instance. Now, here's the original equation, right? And here's the new one. Now, note, if you're trying to find the solutions to the new one, can you do that in your head? What number can you square and get 9? Well, the solutions are both -3 and 3 are solutions to x squared equals 9. Because when you square -3, -3 times -3 is 9, and also 3 times 3 is 9. But -3 is not a solution of the original. In fact, the original was already solved, right? The only possible number you could put in for x to make that true is 3. All right, so actually, let's try to solve some problems where we would want to square both sides. Let's take this example. Square root of x equals 4. So I'm trying to find, okay, what x is, all right? Well, I've got this square root. What's cool about square roots is if you square it, you kind of undo the square root. So let's square both sides. All right, so if I square a square root, I get what's underneath the radical sign. So I'll get x equals 16. And then we're going to check it in the original. All right, so now we're going to check x equals 16 in the original. The original, remember, was square root of x equals 4. So if we put in 16 for x, does this make it true? I'm going to use a little t-bar. So square root of 16, and the square root of 16 is 4. Remember, when you use that symbol, the square root symbol, you only take the principal square root, so it can't be negative. So this side's 4 and that side's 4, so it checks. So therefore, 16 is the solution to the radical equation, square root of x equals 4. Let's do another one. How about if I had square root of x plus 4 is equal to 5? All right, you should be able to do the same type of thing here. To undo this square root, how about if I square both sides? So I'll write this down so you can see the original still. So if I square both sides, I get, the squaring undoes that square root. I simply get what's inside, which is x plus 4, and that should equal to 25. All right, now this is easy to solve. We're just subtracting 4 from both sides, so hopefully you'll all get x equals 21. Now we want to check this. All right, so we're going to check it in the original. So the original was square root of x plus 4 equaling to 5. And we're going to plug in 21 for x. So I have the square root of 21 plus 4. That's really the same thing as saying the square root of 25. And the square root of 25 really is 5, right? So yeah, it checks out. So 21 is the correct solution here. And I use this power rule, right? Now, another way of thinking about this, some people do it kind of in their head. They'll think, well, the square root of what will give me 25? And they could say, well, I know whatever's in there has to be 25, because you know the square root of 25 has got to be 5. So some people sort of reason out that this thing I circled here would have to be the number 25, which actually, you'll see that equation right here when you square both sides. So sometimes, the way people think about things is a little bit different than going through a particular procedure. But using this idea of the power rule helps us. All right, here's another problem. The square root of x minus 3 minus 2 equals 4. Well, the problem with trying to square both sides is I have a binomial on the left. You could think of this square root of x minus 3 as one term and then minus 2 as the second term. So if I square that, it actually becomes quite a mess. So when you're trying to use the power rule, what you want to do is isolate the radical, in this case the square root, which means I need to add 2 to both sides before I want to square both sides. All right? So if we isolate the radical, I have square root of x minus 3 equals 6. Then you want to square both sides. If you square both sides before doing this, you actually have a big messy problem on the left if you do it right. You can't just square each term. There's that big middle term when you're squaring a binomial. All right, now that we have the square root isolated, we could square both sides. So let's see. Let's square both sides. And we have square root of x minus 3 equals 36. Oops, not the square root, just x minus 3 equals 36. And so if we just add 3 to both sides, x equals 39. Now we want to check this in the original. So we have to write down the original problem, which was the square root of x minus 3 minus 2 is equal to 4, and that's where we have to put in the 39 for x. So you can't do it in a later step. You have to do it in the original when you check. So this is the square root of 36 minus 2, which is 6 minus 2, which is 4. And on the right-hand side, it's 4. So 39 checks. So the answer to our original problem was 39. Let's look at one more thing. Let's say you were asked to solve square root of x equals negative 3. Can you take the square root of something and end up with a negative number? By definition, the square root of a number is non-negative. So hopefully you'll recognize that right off the bat, and that tells you there is no solution to this problem, which you could also write this way for the null set or this way. But let's say you didn't pay attention and you were just, kind of plowing through your problems. You might square both sides. And so when you square that square root, you get x on the left side and 9 on the right-hand side. But when you check it, in the original equation, square root of 9 is equal to 3 by definition, and that does not equal to negative 3. So it does not check, and you would still get no solution. Of course, the fast way is to just stop right here at the beginning, right there's no solution. All right, here's a process that makes it easy to solve a radical equation. One, you're going to isolate one radical on one side of the equation. 2, you're going to raise each side of the equation to the power of the index of the radical and simplify. So if it's a square root, you'll square it. If it's a cube root, you'll cube it. If it's a fourth root, you'll raise it to the fourth power, etc. 3. If the equation has another radical, you have to go back to step 1 and 2 again until you don't have any radicals. And then you'll solve, and lastly, you'll check all solutions in the original equation. Now, I said this is the easy way to solve a radical equation, not the only way. In this video, I only worked with square roots, but we'll be doing problems with cube roots, fourth roots, etc. in the next video.